Hi, everybody. Welcome. We are going to talk about our first two lessons of our Unit 1. This is going to be about categorical variables and displaying them, and then also some mosaic plots. So let's go ahead and get into it. So let's say we have our goals over here. We're going to get into Stat Plot for a second. First thing is we got to learn what a two-way table is, or at least refresh what that is. So let's say we had some sort of survey taken to determine if there are, uh, maybe a preference on some sort of building being constructed in a certain city, and you have an informal survey, could be conveniently done. Maybe at a park, you have people just asking others, or uh, maybe you have someone going door to door. But they're getting getting some feel for what is the support of building this new uh, complex or constructing this new building, whatever that might be. So for residents of that city and non-residents, that's what they were asked. So we were asked about the residency status. So I'm going to go ahead and label this up here just so we understand what this is saying. This top row. This is your residency status. Sorry about that. I don't know what my computer is doing. And then over here, this is your preference, right? This is your support level. So we'll say this is your preference, right? Okay. This is a two-way table. A two-way table is a table that displays the relationship or data on two categorical variables. So in this case here, residency status, this is one variable. Because what does it mean to vary? The word variable means it comes from the word vary, right? Not VERY, but VARY, and that means to change from individual to individual. So the residency status itself is one of the categorical, or we call it qualitative variables, right? And so is preference. Okay. Now, some of you may be saying, well, aren't resident and non-resident, yes, no, and undecided, aren't they the variables? Well, not quite. They're actually what the response is to that question. We would call these the levels of the variable. So what this means is residency status is what varies, right? Changes from person to person. But there are only two options for residency status, either a resident or a non-resident. So we would say that resident and non-resident are the different levels associated with residency status. So these are the levels. And then over here, same thing with preference, right? We have three levels of preference. We could have had two. I could have said maybe if I was surveying, said yes or no, but I gave a third level, undecided. So this is the levels of the variable preference. So that's the difference between a variable and its levels. Just like, another classic example is something like temperature, right? When you're talking about temperature, the temperature of a room can be is a variable. It changes every time maybe you measure it, but very easily you could say it's hot, it's sort of medium, or it's cold, right? So the temperature as a category, where we would categorize as hot, medium, or cold, would be the variable, and then the hot, medium, cold would be the levels. So we're going to go ahead and take a look at representations of this data we have from the survey. So we're going to transfer this over to statplot.com. It's a really cool place to make some graphical displays. Statisticians, we always use computers and technology to help make our graphs and do data analysis. Not a lot of it's done by hand. So let's go check that out. So statplot.com, you could do it along with me if you'd like. And let's enter this data in. So we have, if we go to Statplot, your choices are you have one categorical variable with a single group, one categorical variable with multiple groups, and then two categorical variables. Well, we have two categorical variables, right? We care about the residency status along with the preference towards building this new building or constructing this new building. So we're going to pick two categorical variables. The one categorical variable for a single group might be like, I just want to know what the hair color is of all people in my class or something. So that would be one group of people and one variable that I'm measuring for each person, and then we could go from there. So like that would be an example of that. Multiple groups would mean I have the hair color, but I'm measuring the hair color of the individuals in 7 or 8 different classes, or at least 2 different classes, right? So not just my own class. So 2 categorical variables is what we want. For right now, we're going to say that the explanatory variable, we're going to learn a little bit more about what those words mean later, but that's residency status, and then we have preference. So and then we have preference. Maybe I'll add a little bit more to it for context. Preference on construction. This was yes. This was no. Add a row. That was undecided. And then we had resident and non-resident. And we can enter in our data, right? So we're going to enter in, notice how it says count. Count is another word for frequency. Frequency is just literally the number of individuals that fit that category. So our resident, we had 15, 30, and 5. So we had 15, 30, and 5. And then non-resident, we had 40, 90, and 20. We have begin analysis. Let's see what we get. Okay, so what we get, this is called a segmented bar chart. This is what Staplet defaults to, and what it actually does is it converts all of these counts into relative frequencies or percentages or proportions. They all mean the same thing. So relative frequency, proportion out of a total, or percentage, they all have the same interpretation. So these are now relative frequency, and it's called relative because it's out of the whole group. So it's relative to the total number of individuals in that group. So like you'd see like residents right here, right? So the residents, 30% had yes. If you go back up to the table, out of the residents, 15, that's 15 out of a total of 50. 15 out of 50 is 30%. So that's where that 30% is coming in from. And then you had no, or 60%, which makes sense because that's 30 out of 50. And then 5 out of 50 is the last 10%. But they stack in total to 100%, right? Because this bar represents all of the residents in our survey. So that would be 100% of our residents. And same thing for non-residents too. So this is one way to look at this. And you can kind of see what these look like. So some things you could point out would be, within the resident group, there's a little bit of a higher rate of support, at least supporting yes, because there's 30% residents while there's 26.7% non-residents. They're pretty close, but there's a little higher rate for residents. There is no difference between the resident and non-resident no rate, but we do see a little higher undecided rate in the non-resident group versus in the resident group. So right now, if you look at this, these distributions, they look fairly similar, don't they? I mean, the question, there's really not much difference between the two groups. Now, when you look at the raw data, the numbers itself, the raw counts, the frequencies, one thing you should notice is that the non-residents, there's just more of them. There's actually 150 of them, while there's only 50 residents. So there's 3 times as many non-residents as residents. They're a little bit more represented, right, within our survey. So this is what we can see here. So we can see that, in this case, it doesn't seem to be much of a relationship between the residential status and the the preference, right? Because when you look at these two bar graphs, these two segmented bar graphs, they're really similar in distribution. Like the bars are fairly equally sized for each color. So this would tell us that there doesn't seem to be an association. In other words, like if you're a resident or a non-resident, it doesn't seem to influence your preference at all. So we would say that they're almost independent. And we'll learn a little bit more about that as we go. Now, if I were to change something, which I'm not going to do, and make these bars a little differently, like maybe we'll try it here. I'll make this, say, make that 40 and just hit begin analysis, and I'll reset all this stuff. But you can see now, like, okay, maybe we have a little bit more dependence. Maybe non-residents are more likely to be undecided, significantly more likely to be undecided than for residents. But just so you can see if they have similar structure in the segment of bar graphs in their in their columns, then that generally means the preference may not depend on residency status. Just let me just redo this for a second here. Okay, so we're back to where we were. Now we have a couple other options here. We have a side-by-side bar chart. The side-by-side bar chart, basically just takes the segmented bar chart and pulls those bars right off and just stacks them next to each other. So for the resident, they'll take all of these bars and stack them right next to each other to show you how they compare. And then same thing for the non-residents. So that's a side-by-side bar chart. It's pretty common. And you can also see the same thing, like, again, they're equal percentage of the people in each group, 60% for resident and non-resident were or had no as their preference on the construction. And then you can also see that, the other two bars were fairly similar in height. So, for residents and non-residents, they have roughly the same distribution in preference. So it doesn't seem like the preference is related to their residency status. Now, the other option we have is called the Mosaic Plot. And let's take a look at that. So the Mosaic Plot, it looks like a segmented bar graph. It really is, but there is one big difference between this and the segmented bar graph, right? There's a couple things. First of all, these bars are not touching here, and I'll explain why in a second. But in a bar graph, they're generally not touching. In a mosaic plot, though, you notice that the bars are touching. But you should also notice that this non-resident section is much larger than the resident section. And you can see when I hover over here, okay, so if like in the non-resident, we have no 60%. That 60% is referring to the 90 residents here out of the 150 total non-residents. And then but it also says 45% of the whole. And over here, this says 60%. Again, that 60% for the residents is referring to this 30 out of the 50. But now it's saying 15% of the whole. So I want you to think about what that means. So what whole are they talking about? Well, when you look at this survey, there were 50 residents surveyed and 150 non-residents surveyed. So there was a total of 200 people that were surveyed. So if you look at the 90, for example, these 90 non-residents that voted no, that is the 45% of the whole. So if you take 90 and you divide it by 200, you will get 45% or 0.45. So what does that mean? That means that in this box right here, if you think of this box as having an area of like 100%, okay, this big box takes up 45% of that area. And it's 3 times as large as this one, because this was 15%. And moreover, if you just look at the raw numbers here, right, there were 150 non-residents compared to 50 residents. Well, doesn't it make sense that if I were to take, I'm going to try my best to see if, I don't know if it's going to let me write on here or not. It might not. Let me take a quick screenshot. So if you just take a look at this for a second, doesn't it make sense that this large bar over here that's representing the non-residents, if I sort of divide that into 3 sections, doesn't it make sense that it's a group that is 3 times as large? So shouldn't its section be about 3 times larger than the residents? And that's pretty much what's happening, right? So if you were to take this resident bar and copy it 3 times, you would get a bar that is this wide. So because there are 150 non-residents versus the 50 residents, this area is 3 times larger. So why do we use something like a mosaic plot? Well, a mosaic plot, when we're just comparing percentages within a group, kind of like if we were just looking at the segmented bar chart. if we're just comparing those, like it does tell us how what the distributions are for each group. But the one piece of information it loses is what is the weight of those groups? Are we talking to more residents that maybe more residents care about this, or maybe less residents care about this build, or maybe there's more non-residents who visit this area, so maybe they care more about building or not building this new place, right? Think of it as sort of like a restaurant. I'm going to use the ice cream shop example. Okay, you can do a survey of like favorite ice cream, what favorite ice cream by a customer or something, and at the end of the day, if you're that ice cream stand or ice cream shop, whatever it might be, aren't you trying to cater to your, most common customer? And let's say, for example, maybe it's in the neighborhood or something. Maybe it's a bunch of kids. So wouldn't the kids, their opinions carry more weight than maybe parents or older, maybe older people or young adults or something? You would carry more weight. So maybe you would survey more kids versus other groups of people. So maybe 80% of the adults really love vanilla. Well, if that's only a small percentage of your clients, then who really cares? Because maybe for the kids, even though only half of them like vanilla, you still get way more kids that show up. So the Mosaic plot would say, it's great that we have, these proportions that are shown for each group, but we also got to think about, out of the whole group of individuals that we are analyzing, maybe one carries more weight than the other, and we should consider that. So that's where the Mosaic plot would come in, and we can clearly sort of see the breakdown and the comparisons of one group relative to the other one. Hope this helps. If you have any questions, let me know.